All right, we're moving on today, though, because we are working on 2.2 and 2.3 at the same time, solving equations, one-step and two-step equations, very easy stuff. But I want to show you the picture to it first. And so if I go to the next slide, it says x plus 3. These are not base 10 blocks. These are algebra tiles. So I just like to show the picture instead of just doing number crunching all the time. Obviously, you know 5 plus 3 is 8. That's not, it's about the picture. So what we have here is we have red and yellow. What do you think red represents for integer? They're negatives and the yellows are positives. So what do you think the big one right here represents? This is x. And these are 1. So this would be x. And then plus 3. So I'd put 1. 2, 3. So x plus 3, there it is. Go ahead and set it up on your own slide. X plus 3. And you don't have to do this, but I'm going to click and drag across these and just align them a little bit better. And you don't have to do this. I'm just practicing arrange, and I'm going to align to the bottom if I could see where it is. I think that's it. Yep. So there's x plus 3, and then I need 8. So you know what I'm going to do? I'm going to highlight these. I'm going to copy and paste. There's 3. And copy and paste those again. There's 6. And copy and paste, and then delete one of them. That just makes life a little easier. So you just click, so nothing's highlighted right now. I click and then I drag across it and it highlights all of them. You can see they're highlighted. And then I'm going to arrange and align to the bottom.
Well, if you just drag them, there's a red line that shows how to align.
Arrange and distribute horizontally. And you know what? So there's x plus 3 equals 8. The goal is to get x by itself. There you go. So I want to use, and we said this in our notes. If you looked in your notes, you would say that we talked about the additive inverse for properties. The additive inverse is what we're using right now. What is the additive inverse of 3? It would be -3. So is that it? Just like that? Now what? So it says that it's equal and it's balanced. Well, it's not balanced right now because if I just put -3 on the left, I'm going to copy and paste that and put it on the right.
I don't remember doing this.
But now I've done it to both sides. What happens to this right here? What are these called? Do you know what a yellow and a red is called? These are called 0 pairs. So a yellow and a red pair up together. So what I'm going to do is I'm going to click and drag over all of these. And the only thing I'm going to do here is I'm just going to take and I'm going to move it off to the side, so that if my teacher's correcting my work, they can see that. Yep, I took that off to the side right there. It was there, and I took it away. And then I'm going to do the same thing here on the other side. I'm going to click and drag across the 3 0 pairs I have on this side, and then just bring them off to the side to show. I mean, you could actually put it off the side of the slide altogether as well. And now we have x equals 5. Next slide. Go ahead and set this up and then use your algebra tiles. We're just going to do a few of these. Oh,
I thought you were laughing because, like, oh, you don't actually know what you're doing.
No, that would be me this morning. There's 5 of them.
I thought that was a pity one.
No. That was a stupid laugh. I was talking about myself, obviously. And then we have a and -4. Okay, so now the additive inverse to -4 would be a +4.
It's an upper bibidaboo.
Hey, that's what I thought it was.
There's my additive inverse. There is the additive inverse, creating 4 0 pairs. And whatever I do to one side of the equation, I've got to do the same thing to the other side of the equation. So I am going to copy and bring that over here.
Over how?
Yes, I'm a proud Mainer. And then I'm going to highlight these. Why is that new? People are proud to be Mainers.
No, I mean the over her.
And we get A equals 14.
No idea.
So really, another thing as well, we should have been writing our final answers. So let's see, what do I do to get this back? So right here, I'm going to take a text box. Here's the T for text box. Text box, click on it, and then I'm going to come down here and I'm going to write my equation. I want to make my font a little bigger, like 30. And I'm going to pick a color that I want. And I'm going to say 14 equals A. I just grabbed the text box right here, the T. Grab it, and then click and drag where you want it to be. Otherwise, if you just click, it goes like a big, huge.
We were supposed to put that on the other one?
Yeah, that's okay. We'll just keep doing it from here.
Whoops.
That's all right. My bad. I'm the one that forgot. And I'm going to make this even bigger so it really stands out. Let's see. 3 dots over here so I can see my, let's go with 60. There we go. Boom. So the thing about text box is if I'm not on it and I hover on it, I can see the crosshairs come up. But if I'm clicked on it, I just need to make sure that I'm on the outside box to be able to move the text box around. All right, so this is a 2-step equation because you have to do 2 steps. The other one we just undoing, adding, and subtracting. What do you think I need to do first on this? Set it up, I guess. So 5x. I know in my videos I see myself doing that all the time. I'm like, cut out that S. I don't know why I do that. So there's 2, 3. So if we were working on paper, what do you think is the first thing that I'd want to do right now? You'd want to combine your x's together. They're on the same side of the equation. Today they're on the same side. That means I could just add them together. And so
I was putting them together, and then I saw you putting it on the board.
So I would just put them together because I'd like to arrange these so that they were going vertical, not horizontal. So click and drag so they're all highlighted. And I can use the little round thing at the top right here. And I can just pull it until it says 270. That would be 90 degrees I went. And then they're all facing. That's what I really wanted. And I'm going to put the 8x right above it. All right. So what I need to do is I need to split these up evenly for each one of these. That's what dividing looks like. Adding and subtracting, you're adding the opposite. But for dividing and multiplying with algebra tiles, I need to figure out how many of these could go with each one. And I'm going to actually move these over a little bit more. I need to evenly divide these up amongst the 8. This is why we don't do this all the time. It's just the picture. I want my students to see that there actually is a picture to solving everything. Equations. It would take way too much time if we did it like this all the time, but I just want you to see that there is a picture to all the algebra that you're doing. We can see that every single x equals 2. Okay, one more. Another 2-step equation, 4x plus 8 equals 12. Okay, here we go. Undo it. How do I start this problem? What would I try to do first to get x by itself? Casey, you need to undo adding and subtracting first. before you undo multiplying and dividing. So subtracting 8, this is what I'm going to do on this. Ready? Ready for this one? I'm going to take this, copy and paste it, and then I'm going to come up to my color bucket, and I'm going to say, hey, I want some red ones.
Wow.
Boom. Are you amazed?
Radical,
I'm
dude.
so amazed.
See all the stuff that you're learning that you can use in other classes.
Totally didn't know this.
That's why I'm showing it to you.
How would you not know about that?
Did you know?
Yes, actually.
Did you do it at all today?
No. Yeah. Oh, yes, I just did it.
And then I'm going to copy and paste those and put those over here.
You see, you can do the same thing.
All right. And what I'm going to do is remove these ones off to the side.
I can make an imposter.
And I'm going to take the amount that I need here, 0 pairs. There are 8 0 pairs. Then I'm going to highlight my X's and rotate them so that they're facing the other direction. Grab the little ball on top and rotates. Nope. Command Z and start that again. 270. Bring that down here. And then divide up my X's. How much does each one get? X equals all right, when you finish that up, this is your homework. We're going to do notes first, though. These 2 slides are your homework. You just have to drag your answer over. If you have a hard time seeing the slides, if you do Control minus, it'll make the slides on the side smaller. I made it smaller because I wanted to be able to see x plus 5, so 5 equal, x equals, put your answers over there. 5x equals 30. X is being multiplied by 5, so I would divide both sides by 5, divide by 5, divide by 5, and 30 divided by 5 is, and unfortunately, the thing about these ones, I try to do screenshots, but I guess I didn't on these ones. Screenshots move a lot easier, so you have to have the crosshairs on the side of the box when you pull it over. 3x equals 12, so if opposite of multiplying by 3 would divide by 3, divide by 3. 12 divided by 3 is 4. Okay, one more. 14. This one down here, what's the opposite, looking at this box right here? X divided by 2 equals -5. What's the opposite of dividing 2? So -5 times 2, -10. All right, let's go down to the next slide. You can just arrow, oh, not that. So now on this 2-step equation here on this slide, what would I undo first? Where does it say to start? Where's start? Starts right here. So which one would I undo first, the -7 or the dividing of 5? So I would add 7 to both sides, and how much would there be? Add 7, -4, and then how do I undo dividing? So -4 times 5 is -20. So I would take this piece and I'd put it on -20, and it's telling you your path that you're going. It tells you the next problem where to go. Okay, where do I start on this problem? Do I start by undoing that subtracting? Is that where I would start on this one? Because that's what we did on the first one. We undid subtracting first. What do you think? -9 plus 10. And if you need scrap paper to do it on the side, that's fine. Okay, when you're doing it, there you go. So you see the path that you're taking on this one. So this is these 2 slides are the homework assignment for today. All right, let's go to our notes and let's fill in those. All right, so the opposite of adding 7 would be to subtract 7, and we get x equals. You would start by checking is like writing a paper in English. They give you a prompt, and you're like, how do I start writing this? The first thing they usually show you when you're writing a prompt is put the prompt in the very first sentence so that you're answering that. Well, it'd be the same idea here where you're taking the equation and putting it there. Do I know what x is? So I'm going to substitute in -3. And then I'm going to look at my final statement. What's -3 plus 7? Check. What do you think? Now, I will take points off for a wrong check. Let me tell you how this works. I don't ask you to check every single problem, but if you're taking a quiz and a test and you want to check, that's how you're going to know if you're getting 100 on your test. I don't make you check every question. I will say check like the first 5. You'll know when I tell you to check, okay? And so you can get a check wrong because what do you think it would mean if it said 3 equals 4? What is that supposed to tell?
You put the line through it.
But what is that supposed to tell the student?
You did it wrong.
You did your algebra wrong. So let's say that it says 3 equals 4 and you do what Hunter said and you put a line through it. Fine. You don't have to go back and change your answer if you don't want to. You actually got the check completely right, but you would get some points off somewhere in the solving part of it. But let me tell you how you're going to get more points off. Is if you have a wrong answer and when you check it, you try to fake it and put 4 equals 4. That would be, all of this would be wrong then. The check would be completely wrong. You need to realize it's better to show that you know how to check and get a false answer and you're okay, that you don't want to go back and check your algebra and get the right answer. That is more algebraically sound than the person who's going to fake it and lie at the end over here. Okay? All right, here we go. The opposite of subtracting 12 would be to add 12. You're showing those 0 pairs are canceling. And we get x equals 15. And when you put down x minus 12 equals 3, and then you substitute in, and you're showing that 15 minus 12 really is 3, that's a check. If it doesn't say the same number equals itself at the end, okay, if you don't have something down to show a check, you're not going to get credit for it. You can't just put down 3 equals 3 and that's it. It's your evidence. All right, here we go. Now undoing multiplication. The opposite of multiplying -6 would be to divide -6. Divide -6. -6 divided by -6 is actually 1, which is what's understood to be in front of the x. There's understood to be a 1 there. You don't see a number, but if it was 0, would it even exist? What's 0 times x? 0. So it can't be a 0 that's in front of a variable. It has to be a 1. It's the first 1. And then we get 48, it would be -8. Positive divided by a negative, and then I check. -6x equals 48, -6 times my x. And again, these are just your notes. I'll make you check maybe 5, make sure you understand it, and then on a test, maybe 1. But I do give bonus for people that check. You want bonus? I give it because you're going out of your way. So I'll go out of my way. What's being done to x? What's the opposite of dividing 4? So I'm going to multiply 4, multiply 4. I can see if I made the 4 a fraction, 4 in the numerator would cancel the 4 in the denominator, which is why we're left with x equals 20. Number 5. All right, and number 5, in junior high school, you would do this in 2 steps. First, you would undo the dividing, then you would undo the multiplying. But we just like to do it in 1 step when we get into Algebra 1. And so how can I do this in 1 step? I need to have just an x left. So you have to ask yourself, what is going to make the -2 sevens cancel to be a 1? Which one of my properties was Yes, that's right, the reciprocal, the inverse of multiplication. And so I could multiply this by -7 over 2. Doesn't matter where you put the negative. You only need 1 negative. It can be out front. It can be on top with the 7. It can be in the denominator with the 2. But either way, you can only have 1 negative. And then if I come over here and multiply by -7/2, I would see that the 2's in the numerator and denominator cancel, the 7's the same, and then a negative times a negative actually is positive. That's why I had to multiply by that negative. I need a positive x. I can never have a negative x. And then I just need to multiply 4 times negative 7/2. So what do? Make 4 a fraction. Look for any cross canceling. Is there anything that's going to cancel to make my numbers smaller? I can cross cancel 4 and 2. The common factor is 2, so 2 divided by 2 is 1. 4 divided by 2 is 2. And then you multiply straight across. 2 times negative 7 is negative 14. And 1 times 1 is 1, but I don't need that. Negative 14 over 1, I don't need it. Substituting in negative 14. Again, I could make this a fraction. Cross cancel 7 and 14. And I have negative 2 times negative 2. I'll be looking for that evidence. Your algebra actually has to make sense. Again, not everybody does everything the same, but whatever I look at, it has to make sense. It says negative 2 times. If you didn't have a negative, and it should have said negative 4 equals 4 because you forgot one of your negatives somewhere, then that's what it says. It's better to get just a tiny point off than to get the majority of it wrong. So we do have negative 2 times negative 2. Check. Olympics, the 2004 Olympics, Sean Crawford won the 200-meter dash. His winning time was 19.79 seconds. Find his average speed to the nearest tenth of a meter per second. Any idea how to start this? Do we have anything to work with from previous sections, like 2.6? If you're not sure, you could look at 2.6 and say, what the heck is she talking about? Why does she know there's something in 1.6? I'm sorry, 1.6. What is there in 1.6 that might help me here? I wonder which one of these is going to help me. Temperature, simple interest, profit, or distance? What do you think? Distance formula. Distance equals rate times time. The distance was 200 meters. What about 19.79? Where does that go? That's the seconds and the time. So 19 point, ooh, I don't like that like that. So I'm going to switch to parentheses. I don't like that timesing dot with a decimal. What's the question asking about? Find what? Find, what's the question asking? Find what? What's the 2 words? Average speed is rate, like miles per hour. Rate, how fast you're going. So what's being done to R? It's being multiplied. And how do I undo that? Divide by 19.79. Divide by 19.79. And this was seconds. I should have had seconds in there. Because what's my rate going to say? My rate is going to say meters per second. And then you could use a calculator on a word problem. Even if it doesn't say it, I don't mind on word problems. 200 divided by 19.79 is 10. What they said they want it to the nearest tenths right there. So 10.1 equals R. Boom. Boom, chicka boom. 10.1 meters per second. 2-step equations. So 2-step equations, now there has to be some order to it. Okay? So we're thinking about PEMDAS, and I go forward when I'm simplifying expressions. I go forward. Well, when I'm solving, everything has an opposite. I mean, think about it. When you go home and take your shoes off today, are you going to take your socks off first? Yeah. They're in a hurry, right? So you put your socks on, you put your shoes on. Well, there's a reverse order to that. You take your shoes off, you take your socks off. Same thing here. I need to go backwards when I'm solving. Still has to hold some kind of order. So we are definitely on solving, so we're thinking about PEMDAS backwards. That's why you have to undo adding and subtracting first. And then you undo multiplying and dividing, then exponents and so on. So I would undo adding and subtracting first. The opposite of adding 5 would be to subtract 5. And then I would finish by undoing dividing. The opposite of dividing is to multiply by 2. Dividing by 2, I'm going to multiply by 2. Cancel, I get x equals 12. Now I'm actually simplifying by using PEMDAS forward. I would start by, are there any parentheses? No. Any exponents? No. Any multiplying and dividing? Yes. I would start with that first, 12 divided by 2. And then I would finish with my addition. So we will just cross out justify for today. Justify means you're writing down properties. Like I would have said additive inverse and then multiplicative inverse. You're using properties to justify why you're doing what you're doing. All right, finish example 2. 7x minus 4x equals 21. They're on the same side of the equation, so I can do exactly what it says. 7x minus 4x. The output of a function is 3 less than 5 times the input. What does output and input stand for? What's output? So if we look at 1.7, we wrote it down in 1.7. So I'm going to put above input, I'm going to put x. And above output, what am I going to put? I'm going to put those there to remind myself when I'm taking a test or I'm doing homework and I look back, I can see where I got those variables from. All right, so it says the output of a function is. What does that mean? How do I start writing that? The output of a function is y equals. Is means equal, so y equals 3 less than 5 times the input.
So 5x minus 30.
3 less than, yes, and then 5 times the input. There we go. There's the first part. It says find the input when the output is 17.
So erase 1.
No, don't erase it because I would need to make sure that you can actually write that and then put 17 equals and solve. Then you can work on your homework.